Okay, now we got the T1 over T2. Yeah. Now we need to find out the T2. So the easy way to find out the T2 is you just flip this and you flip that side as well. When you simplify this bit, that becomes a gamma 1 minus gamma, like that. Yep. So the equation will be given as P2 over P1 over gamma, and on this side it's a T1 over T2, but we want T2. T2 is the temperature that's missing. So what you can do is you can flip this side and flip that side. So when you flip this side, that becomes a T2 over T1. But on this side, when you flip, you can keep everything same, but you can do a tiny trick. You can just do gamma minus 1. So they come here and that move. That's a rule of indices. Now I need to find out the T1, sorry, T2. So I can move the T1 on the other side. So the T1 I can delete from here and I can put here. After I put that one, I will go and I will put the values of the missing bits. So let's put the values. Pressure 2, if it's kilo, just put the kilos because they will cancel. You don't need to convert. Pressure 2 was 100. So I put 100. Let me write on this side. Yeah. So let's do that one. Yeah, maybe here. Yeah. So that's pressure 2 was 100 kilopascal. Pressure 1 is 140 kilopascal. Temperature 1 was 450. I don't know the value of the gamma. Gamma is an adiabatic index. Usually the value for the adiabatic index is 1.42. So we take that value 1.4, 1.42. So I'm just going to put gamma equals 1.4, this value. So 1.4 minus 1, 1.4. If you put all these bits as a single go in the calculator, that will give you the value for the T2. Now when doing that one, we need to do two main things, two changes. First thing is this is in centigrade. So you need to make sure you add 273 to convert into Kelvin. So we'll get answer in Kelvin as well. The other thing is this 140 was the gauge pressure. So you need to actually add another 100 here. So that 140 becomes 140 plus 100 because we need to add that one. And then you put that in calculator to get an answer. Okay, now we got the answer as 563 Kelvin. Now we got the temperature T2. Now once we got the temperature T2, which is that temperature, so we got the temperature T2, we need to find out the mass flow rate. We got an equation, W equals to M Cp T2 minus T1. Now there was a dot here and there was a dot here. So we got this value already. We are trying to find out the M dot. So if I make the M dot the subject, M dot is going to be W dot. And all these things that's being multiplied with an M will come here. Cp T2 minus T1. The Cp is again a constant. So it's a specific heat capacity of an air at constant pressure. And that has a value as well. The value for Cp is 1010 joules per kilogram per Kelvin. Yeah. So Cp has this value 1010. If I write it down here, Cp for the air is 1010 joules per kilogram per Kelvin. Yeah, that's the value for that one. T2 we just calculated 563 minus T1, which we have. T1 was 450. Yeah. So T1 was 450. So the value for the T1, which was 450, you add 273. That will be, thank you, 723 Kelvin. So I need to do that one here. Now W dot, the work done by the turbine is given. It's a minus 80 kilo. Yeah. So I can write minus 80 for the kilo. I can put 3 more zeros. And I put that in the equation, and I will have a mass flow rate. The unit will be in kilogram per second. Top is minus and the bottom is going to be minus number. They will kind of cancel, and you will get 0.95 kilograms per second. This is how much mass of the air need to go inside in the turbine to produce a work of 80 kilowatts. Now let's do a key for different things. Now we got, if I just drop this one, so we got P is pressure, V is volume. Now there's a difference between that V and that V. The top V is the volume, the bottom V is the velocity. One V is like that, and the velocity V is like this. So there's a one arm is like a little bit curved. Yep. Yes. So the pressure is Pascal. The volume is meter cube. The velocity is meter per second. T is for temperature. And we always convert into Kelvin. If it's given in Celsius, you have to add 273 because all the gas laws, they work in Kelvin. Then we got the M. M is mass. M dot is mass per flow per second, mass flow rate. And the unit is kilogram per second. Cp is specific heat capacity. Now for air, if it says for air at constant, this is at constant pressure. For air, its value is 1010 joules per kilogram per Kelvin. Yeah. Then we have a CV as well, which is specific heat capacity. At constant volume. Yep, so that's that one. Yes. So W is work done. But if there's a W dot, work done per unit time. Now, the unit for work done is joules, but with dot, joules per second. The unit is watt. Q dot is heat transfer per second, rate of heat transfer. And same unit. So that W is different than that W. Yep. And then we got the gamma. It's an adiabatic index. If the value is not given to you, just use this value as 1.4. If the value is given, then use that value.